Hi there. Today I'm gonna fix this emergency light. This is a product from Eveready. According to the product description, it says 360-degree white light, which is true. Compact, lightweight, yes. It is powered by nickel metal hydride battery and it has 500 recharge cycles. I'm not sure about that, but still we use it for a very long time and it works as promised. Product description also says it can work for 4 hours non-stop, which is true. Two light options, 6 LED and 12 LED. The discharge and overcharge protection auto on during power failure. All of these claims are absolutely correct, no doubt in that. But after approximately 5 years, the battery is dead, which is obvious. So today in this video, I will replace the battery, but unfortunately I don't have a nickel metal hydride battery, so I'll replace with a lithium ion battery. But it's not 100% safe because the circuit is designed to charge nickel metal hydride batteries. So let's see what could go wrong if I replace nickel metal hydride battery with lithium ion battery. But first, we will fix this. After that, we'll see what will happen if we do so. So let's get started. And feel free to skip the repair section. This is the light which I will be fixing. The issue here is battery is almost dead. It cannot hold charge for a long time and the LEDs are not glowing bright enough as they used to be when it was new. Everything will be fixed if I replace the battery. For that, I have to open it and replace the battery. First, I tried to open using a tester, which was a disappointment. Later, I used my trusty old screw drill to unscrew. Now we have opened successfully. You can see this is a push button which will turn on the LEDs. I can also see that it uses transformerless circuit design to charge the battery. Now it's time to free the battery from its cage. I have used smaller screwdriver since my driller bit screw is too big for this task. After carefully removing the battery and checking its voltage rating, I brutally cut the battery wires, and started adding lithium-ion batteries and tested it before making more stable wire joints. As expected, my batteries were dead since I did not charge them for a long time. Finally, I added a good one and reassembled everything. And now the product works as new with an added advantage that the battery backup is more than before. So let's just have a quick glance. What are the parameters we should consider before doing this kind of hack? Charging voltage, charging current, discharge voltage, discharge current, operating temperature, overcharge protection, and over discharge protection. First, we have to check the charging current and charging voltage. So, according to the specification, it seems they have used 3.6 nickel metal hydride battery, whereas I have replaced a lithium ion battery, which is 3.7 volt. According to the Google search results, the nominal voltage of nickel metal hydride batteries is 1.2 volt if it is a single cell. So in our case, three of the batteries are stacked together. So that means we'll be having 3.6 volt, which is what I removed from the old from the setup. And it also mentioned like the maximum charging voltage is 4.5 volt, which is quite high when we compare to the lithium-ion batteries. But again, one more website also suggests that it's just 1.41 volt to totally to fully charge the battery at 20 degrees Celsius. So according to that, it's 4.23 volt. You're charging the battery at 20 degrees Celsius. Means when you're charging a battery at 20 degrees Celsius, it should be 4.23 volt, but the normal room temperature is 27, so I guess it should be higher. But well, we can only confirm when we check the circuit. Since it is in transformerless circuit design, I don't think so. The voltage will be as precise. It highly depends upon the circuit because most of them they'll connect a series resistor to limit the current, but still open circuit voltage will be higher than 4.5 volt. Anyway, our BMS will take care. For your kind information, most of the cell phone batteries comes with an inbuilt BMS, so it should be fine to use them for a DIY hack. Since we replaced with an almost identical battery, so most of the troubles are solved except for the shut off and overcharge protection logic. Based on the rough calculation, everything seems to be fine for now, and rest will be taken care by inbuilt BMS. So since the battery is pretty much the same, so discharge voltage and discharge current are kind of fine. Operating temperature is okay. Overcharge protection, discharge protection. Maybe if the battery blows up, I will definitely make one more videos to explain where we went wrong. So I hope you enjoyed watching this video.